and man-made disasters is a significant part of our. Good morning, everyone, and thank you for joining us for today's webinar. Living in the Caribbean means that preparing for and responding to natural and man-made disasters is a significant part of our daily lives. With the effects of climate change exacerbating the already severe impact on life, property, and the environment, it's crucial to have geospatial awareness to manage crises as they arise. An emergency management system that integrates data on the who, where, what, how, and why of a disaster is essential for informed decision making. This information can help create evacuation and shelter plans, assess damage, prioritize rescue efforts, and allocate resources more effectively. By understanding the location of hazards and potential disaster impacts, emergency managers can develop plans to reduce risks to life and property. Today, we will explore the ArcGIS platform as a critical tool for holistic and strategic planning and response in emergency management. In today's webinar, we will explore how ArcGIS serves as an all-in-one solution for emergency management. We will explore various ArcGIS applications throughout the disaster management environment. ArcGIS is a powerful and comprehensive platform that utilizes geographic data to analyze, visualize, and interpret information using interactive systems. By integrating various data sources, ArcGIS provides a deep enables it to function as a system of record, insight, and engagement, allowing users to store, manage, visualize, analyze, and share spatial data. Emergency managers benefit from accurate and up-to-date information, enabling data-driven decisions that save lives and resources. Effective ArcGIS integration promotes seamless communication among stakeholders, avoiding redundancy and ensuring a coordinated disaster response. ArcGIS serves as an efficient and reliable system of record for storing and managing geospatial data encompassing maps, images, and other spatial information. Its comprehensive features, including data centralization, geospatial data management, versioning, security, access control, metadata management, visualization, relational database support, attachment support, data editing, updating, sharing, and collaboration, serve to ensure seamless data handling. By securely managing crucial data related to assets, infrastructure, and risks, ArcGIS plays a vital role in monitoring disaster aftermath, facilitating well-informed decision-making, and enhancing preparedness for future events. The platform's unified data source guarantees that all stakeholders involved in the response and recovery process access identical information, promoting coordination and efficiency. ArcGIS also promotes collaboration between and among different agencies, enabling real-time information sharing between frontline responders, command and control, and logistical teams. This ensures effective resource utilization that everyone that everyone is working from the same reliable sources. As a result, ArcGIS empowers disaster response efforts and enhances overall situational awareness. ArcGIS transforms into a potent system of engagement by offering an array of features that foster collaboration, communication, and coordination among stakeholders in disaster and emergency management. With interactive maps, crowdsourcing, social media interaction, real-time data feeds, collaborative workflows, web-based access, notification, and data integration, ArcGIS becomes an essential tool for preparedness, response, and recovery. It enables seamless communication between diverse agencies, organizations, and members of the public during a crisis, combating the spread of inaccurate information and promoting trust. Empowering communities with resources and tools, ArcGIS allows them to assess risks, develop plans, and take control of their disaster preparedness and response effectively. The application of a system of insight is paramount for emergency managers aiming to enhance decision making, operations, and innovation. Fortunately, ArcGIS offers a comprehensive suite of tools to achieve these objectives in disaster management and emergency management. Through ArcGIS, both planners and responders can analyze complex spatial data, gain insights, and make well-informed decisions confidently. The platform's geospatial data analysis tools, encompassing spatial analysis, visualization, temporal analysis, real-time data integration, risk assessment, scenario modeling, customizable dashboards, and data sharing enable ArcGIS to evolve into a system of insight. It equips decision makers with crucial spatial intelligence, enabling them to comprehend complex situations, predict outcomes, and take data driven action to save lives and minimize disaster impact. ArcGIS empowers users to generate, manage, analyze, and share geospatial data. It is a highly sought after tool by various organizations, emergency managers, first responders, and civil society organizations. Unlike other solutions, ArcGIS offers a unified software solution that seamlessly integrates both spatial and non-spatial data for optimal data management, geospatial awareness, mapping, and collaboration. The ArcGIS ecosystem boasts three distinct levels, each serving a unique purpose. ArcGIS Online for cloud-based access to geospatial data and tools, ArcGIS Pro for robust desktop application use, and ArcGIS Enterprise for scalable enterprise use. Emergency managers can confidently leverage these powerful tools to analyze data, track progress, and communicate with the public during critical moments. ArcGIS also enables the planning and coordination of responses between various agencies, providing an essential resource for effective emergency management. ArcGIS is a versatile and crucial tool for disaster management, enhancing an agency's effectiveness throughout the response cycle. It aids in vulnerability assessment, mapping of hazards and high-risk areas, leading to targeted mitigation and evacuation plans. ArcGIS supports the development of effective mitigation plans, tracking their implementation for assessment. Emergency planning is facilitated through mapping emergency resources, enabling strategic resource deployment during disasters. Real-time data and maps, including weather and social media information, assist in making informed decisions. ArcGIS tracks and communicates with mobile workers, ensuring their safety and effective deployment. Enhanced stakeholder collaboration fosters information sharing, building of trust, and coordinated responses. By harnessing ArcGIS in these areas, disaster management efforts become more effective, coordinated, and responsive, ultimately benefiting the affected communities. ArcGIS is a highly effective disaster mitigation tool, enabling data collection, management, and analysis related to hazards, risks, assets, and people. It aids in risk identification by analyzing historical data to pinpoint areas vulnerable to specific natural and man-made disasters. The platform is essential for developing mitigation plans, devising strategies like building levees, and erosion prevention measures. ArcGIS facilitates risk communication through maps and visualizations that are clear and easy for public understanding. It also monitors hazards in real time, allowing timely resource deployment and tracking of storms and other disaster information. This valuable resource empowers communities to take proactive measures in reducing natural disaster risks, enhancing preparedness, and ensuring a safer and more resilient outcome. ArcGIS is an invaluable tool.
Hello, today I'd like to show you how ArcGIS can support a modern approach to hazard mitigation planning. Now, traditionally, this is a paper-based process, and from a GIS perspective, you can't interact or use from an analytic perspective for operations or response all the great hazards and risk data that's been collected as a part of the process. So what I'm going to show you today is configuration of ArcGIS apps in an ArcGIS hub site for a notional update to a local hazard mitigation plan. Now, this has many benefits, including helping you modernize and operationalize the hazard mitigation planning process, help you engage and inform your community, and obviously with the goal of keeping them safe and helping you increase the resiliency in your community. And finally, to help you more effectively meet FEMA requirements and, more importantly, get FEMA funding to support a lot of your work. Now let's begin the tour. So what we're looking at here is the configuration of the hub site, and this is intended in this case to be public, but certainly this could be gated as well, and we can start to explore some of the elements of the hub site here. So first off, we can look at what are the high-risk areas in the jurisdiction. Now this represents a lot of the hazards data that's been collected and displayed in an interactive format that we can start to peruse through. We can look at the flood hazards, wildfire data, hazardous material routes, basically whatever hazards data we've collected as a part of the planning process, we can operationalize in viewers like these. And this can be, hazards data. We can also look at, historical occurrence data too, like historical tornado tracks or hailstorms, windstorms, wildfires, whatever the hazards may be in your, jurisdiction. Now, obviously, this is kind of from an overview perspective, but we can also zoom in and get, more details on any area. So, for example, if I want to look at this area in particular, and now I can start to see, in a more zoomed in fashion, the various hazards around, this area, including more detailed, wildfire hazards data, the closer that I zoom in. So that's, one section. So part of the purpose of using ArcGIS Hub is it's a great way for us to engage the community. And there's a variety of ways that it allows us and enables us to do that. Obviously we're, kind of looking at the traditional, PDF view of the previous version of the plan. But using some of the Hub features, we can, follow this initiatives, using some of the Hub conventions to get, various updates. We can interactively encourage feedback from the community. In this case, having them use a survey 123 form to, provide, specific suggestions on how they'd like to be, contacted and any other kind of additional, data or information that they'd submit, as a part of the process. Hub also has a convention for events as well, in advertising events that may be happening in your jurisdiction. So in this case, if there's public planning meetings that have or will happen as a part of the process, we can use Hub as a way to sign up and share this data. Obviously, show where it is on the map, and this is just another feature that you can interact with and leverage as well, and including also things like including the social media tags and the like. And then finally, at the bottom of this page, just a shout out to the various partners that helped participate as a part of the process, and in this case, just providing links to the logos to the various other various agencies. So that's the first page here. We can on the second page drill in and see more details about hazard and risk. In a similar fashion, we can explore the FEMA's National Risk Index data that's specific to the Travis County area that we're using for our demonstration, and look at specific risk around the categories of data that they provide, in this case in the census tract data for wildfire, heat wave, hail risk, tornado, and the like. So there's about 18 different hazards that are available as a part of the National Risk Index. Not all of them are germane here to this area of Texas. And also a big component of that is, social vulnerability and community resiliency as well. And now all of this has been operationalized in a way that makes it easy for users to interact with to get more information about the risks and vulnerability in the jurisdiction. And then finally, we can look at this in more detail and explore specific risks, within the community. So in this case, if we want to look at this particular part of the flood zone, so this is the 500-year flood zone in Austin, Texas, we can get more specific details on, essentially the assets or the things that we care about in our community that could be potentially impacted if flooding were to happen in this area. So we've got, 70 building, footprints, library, fire station, some, government buildings, and this viewer can be configured with any, data that you want to help, tell you, what, particular assets, critical infrastructure, things you care about, may be exposed to different hazards like flooding or wildfire, whatever the case may be. So, yeah, this completes this section. And then finally, what can we do about some of these issues and challenges? What are some ways that we can help reduce the risk in our jurisdiction? Well, what we're looking at here is, looking at both proposed and mitigation projects that are actually kind of occurring. So instead of inventorying those mitigation projects in an Excel spreadsheet or a table in a PDF document, we can have those be living in a plan like this, in an element like this. In this case, a dashboard, to see more details about each of the specific mitigation projects, and we can kind of flip through the different ones that are indexed here. And there's a whole schema for how this is managed on the back end for things like the phase and what fiscal year that these will occur in, the funding, and whatever basically details about the particular project that you want to track as a part of the process. So obviously things to come, obviously projects here to help reduce our risk and increase our resiliency within our community. And then finally, just kind of a tip of the hat to how this can be integrated with other existing planning efforts that, through various community or national initiatives. So yeah, so that was basically a quick tour to show you how ArcGIS Hub can help you modernize your hazard mitigation planning approach. And you've seen how we've been able to digitally operationalize hazard mitigation plans, interact with GIS-based risk assessments and interact with them in a new and compelling way to leverage their data for more analysis. And then finally, you saw inventorying and tracking mitigation projects in a modern way as well. So that kind of completes the tour of the demonstration. And last thing that I'd like to mention before closing is this is actually a Hub initiative template. So this is something that you can get started with, today. So if you go into ArcGIS Hub and you were to create a new initiative here, we can actually browse to this particular template. So I'll search, not my organization, but the kind of global set of templates, and just type in a couple of keywords here, and you can see this, Hub initiative template. I can hit the activate, button, and you could get, started very quickly on your own with something, very similar. And this, I'd like to give credit to Shelby Hines from Esri Professional Services and the Esri Denver office for putting together this initiative template that we've been able to leverage and simply configure for today's, demonstration. So thanks for watching.
ArcGIS is an invaluable tool for responders and planners during the preparedness stage of the disaster and emergency management cycles. It aids in hazard identification and the development of plans, policies, and resources to handle disasters confidently. Creating evacuation plans with safe routes and locations simplifies planning. ArcGIS facilitates public information on disaster preparedness through visualizations and risk information. It ensures that everyone is informed and ready to respond if needed. Additionally, ArcGIS is instrumental in training emergency responders to effectively use the geospatial technology at their hands, enabling better resource allocation and public protection during disasters.
Today I'll be discussing Esri technology capabilities in supporting emergency management workflows, and in particular, the preparation for natural disasters. We will focus on one of Esri's solutions known as the Flood Impact Analysis solution. Flood impact analysis can be used to develop localized flooding scenarios and visualize the impact of flooding on public infrastructure, critical facilities, and vulnerable populations. This solution has been carefully crafted to streamline the data analysis intensive process of making predictive flood impact maps. Using your base data, the ArcGIS Pro project attached to this solution walks you through the procedures of data preparation, management, and analysis, and the sharing of the final outputs, taking you from start to finish. Before we get into the details of this solution, I'd like to provide a bit of context for the use case of this technology, and how, by adopting a modernized geospatial approach, local, state, and federal government agencies can protect people and property by becoming better prepared for disasters. All of the information and technology I will be speaking to today is housed within this story map, an excellent platform that is enabled to support Esri applications as well as communicate location-based information. To begin, flooding is by far the most common form of natural disaster experienced by American communities. In fact, a whopping 98% of American counties are prone to flooding. For this reason, in most communities, flood preparedness is a high priority and requires diligent planning efforts. In this demonstration, we've chosen to use Austin, Texas as our area of interest. The city of Austin is located within what has become known as Flash Flood Alley. This region of Texas, stretching from Dallas in the north to San Antonio in the south, is especially prone to flooding due to a number of climate and topographic factors that culminate to produce semi-regular flash floods, often resulting in devastation to infrastructure and displacement of people. Here in this map, we can navigate between some of the major cities within Flash Flood Alley. Added to the map is the National Hydrological Dataset, containing data representative of the water bodies that exist in and around these areas. As you can see, each one of these cities is within very close proximity of both lakes and rivers, prone to breach in the event of severe and prolonged rain. Moving on to our next section, we've provided a viewing application housing map excerpts from FEMA's National Risk Index. Here we have isolated flooding hazard and have highlighted those same cities once again. Emergency managers can utilize NRI in order to understand how a particular hazard might affect their community in terms of severity as well as the impact to specific demographics.
Let's now get into the flood impact analysis solution. This solution is a part of a larger collection of ArcGIS solutions oriented towards emergency management and focuses on the preparedness stage. It is typically implemented by emergency management, public works, and planning organizations that want to prepare for future flooding to protect their communities. Using the simple data inputs previously mentioned, visualization and impact assessment can be achieved.
In this next view, we've displayed the results of that analysis. Using just a digital terrain model, flood depth raster, and our infrastructure data, we created 3 separate flooding scenarios ranging from minor to extreme. This first scenario displays the flood extent of a 5-foot flood depth. Notice darker colored infrastructure represents a high scale of impact, while lighter color represents relatively low impact. Next, we can see the progression of a moderate flood of 15 feet. Notice the flood extent has spread considerably, now impacting a greater area and thus much more infrastructure. Finally, an extreme scenario of 25 feet results in extensive flooding, likely causing severe damage to infrastructure. We can see here entire regions of the city are likely submerged, and the entire riverbank lining the southern border of the city has been breached. This visualization is especially useful to interpret the toll of impact given different scenarios. From the point of view of an emergency manager, given these insights, allocation of preparatory resources may be directed to certain areas in advance. Additionally, with this knowledge, evacuation plans and routes can be designed taking into account the likely path of flooding.
This next section gives you an idea of how the ArcGIS Pro project, which is central to this solution, facilitates geoprocessing, ultimately lowering the barrier of entry to conduct complex analysis and return invaluable information. Each screenshot represents a different step of the process. The final image is the toolbox that is provided by the solution and houses the different custom tools that enable the processing of your data. Finally, I'd like to briefly cover an example of how the data created by flood impact analysis can be harnessed within an Esri web application to provide additional insight beyond visualization. Let's step into this experience builder, which has 3 separate dashboards nested within it. Here in the first dashboard, we can see that although this is considered the minor scenario, damage still certainly occurred. Changing the extent of our view, we can see that the data represented will update to reflect that view. On the right is a list of all the low water crossings affected by this flooding scenario. Moving on to the next dashboard, we can see that an additional 10 feet of flood depth results in substantially more impact to infrastructure. While this is clear through the map visualization, pulling out the numbers communicates this information in exact terms. This sort of information is critical in the preparedness stage of emergency management to not only understand where in your community a flood will likely occur, but the full extent of impact of that theoretical scenario. Finally, under the extreme scenario, the trend continues and is only heightened further. These dashboards are only one example of how to leverage the data created by the flood impact analysis solution. Think of the outputs of your analysis as merely the starting point. There is really no limit to the knowledge emergency managers and community planners can gain from the exercise this solution provides. This last section of the story map provides additional resources that may help you orient your thinking in developing flood impact analysis for your own community. Today I'll be discussing Esri technology.
ArcGIS plays a crucial role in enhancing disaster response by providing real-time situational awareness, spatial analysis, resource management, and interagency coordination capabilities. By integrating data from various sources such as weather updates, social media feeds, and IoT sensor networks, ArcGIS equips responders with up-to-date information, enabling quick decision-making and efficient resource allocation. Moreover, situational awareness ensures responders are aware of the evolving conditions, allowing for agile and adaptive response strategies. Additionally, ArcGIS fosters public engagement by providing visualizations and maps that convey risks and preparedness instructions, enabling the public to be informed and take proactive measures during disasters. The combination of situational awareness and public engagement empowers responders to effectively collaborate with communities, enhancing overall disaster response efforts and minimizing the impact on lives and property.
Effectively maintaining situational awareness is important to every emergency management agency, and frankly, any organization with an operations component. I'm going to show you how ArcGIS apps can be used to monitor changing conditions, put plans into action, and brief teams in real time. In the Operations Center, staff need to be able to monitor current conditions and key metrics in both blue and gray sky days. This allows operations staff to have a current understanding of the situation at a quick glance. Here we are looking at a configuration of the operations dashboard to show current conditions for Baltimore, Maryland. We can see live feeds of information like weather warnings and watches, and we can zoom out to get a better sense of what's going on at a regional level. Here we can see the current flooding situation along the Jones River, where they have received a lot of rain in recent days. This is the scenario that we're going to focus on for these demonstrations. Here we can see the state of the current situation: 43 open shelters, 25% occupancy, 7 points of distribution, 4 road closures, 2 mission-ready packages. This application allows staff to come into the command center and get a quick glance to get an idea of what's going on, not only from a mapping perspective, but also by looking at key performance indicators to get a better sense of the situation. The Operations Response Viewer provides staff the ability to update and edit information without having to go through the GIS staff. In this case, with a couple of clicks, I can simply update information like shelter status. And these updates are immediately available in other apps throughout the system, like the incident dashboard that you're looking at here. And we can see the number of shelters change from 43 to 44. This is the main editing app that can be used by operations staff to help keep incident information up to date. Using story maps, we can brief teams in real time using the same information that's used for planning and operations. Instead of using paper maps or static PowerPoints, which are immediately out of date, we can use a roll-up of live data and apps to provide better context to explain the situation so better decisions can be made. Effectively maintaining situational awareness is important to every emergency management agency, and frankly, any. Now, let's talk about the information sharing capabilities for emergency management operations. First, let's talk about sharing information with the public to provide them additional details and provide them resources to keep them safe. More and more, we see agencies turning to ArcGIS Hub to provide a single destination for people to go, to put apps and data in context, and to provide situational awareness information to both the curious and concerned public. So in this example, for our Austin flooding scenario, we can see this hub site is telling us key pieces of information already, like the number of road closures, evacuation notices, open shelters, and the like. We have more context with the embedded map right here inside our web page. This also serves as a launching off point for additional information and resources, such as the ability to find open shelters or volunteer to help, key social media feeds, and the like. Damage assessment information, including the ability to report in, damage on your own, and we'll talk about this in another, section. And all of this is, pretty configurable to meet your information sharing needs. But here, let's dig into more details about this, evacuation map, and in the specific public information map that has been configured for this particular, incident. So in this case, the public can come in and view this, map and either click on the map or simply type in their address to get more details on what may be, impacting them. First of all, are they in evacuation zone? Do they need to get out of the area? Are they in harm's way? What are some of the resources that are available to help them? Like, for example, what are the nearest shelters, and the like. And so this map is configurable to help, kind of meet the needs of sharing information, with the public. But one thing that we wanted to convey here is this particular app is designed to work, well on mobile devices. And obviously, many times the affected public would be, interacting with the map here on their mobile device. And so it's critically important that we have an application that's designed well to work in this environment as well, and this kind of form factor to allow the public to be able to interact with the map here on their mobile devices, as they may not be, home when they get the evacuation, notice. A couple of other things here to talk about from a public information perspective is, we wanted to make this really easy for communication staff or public information officer staff to share with the public. So they can, copy a link, or we make it really easy to embed in their agency's, Facebook page, or share it out via, social media like Twitter. And time again, we see, when, communication staff share this information out, publicly, and kind of meet the public where they're at, that it can really help to calm the situation by, providing that transparent information and providing constituents, access to key information to keep them safe and out of harm's way. So some other additional kind of critical important, features, here that are helpful from an information sharing perspective, especially with the public. Now, another key feature here that we wanted to highlight is the internal information sharing. So as we can see here in this application, this top row, this top card of information provides, quick access to the situational awareness applications for internal, operations staff. So it's kind of a way to have, kind of at a glance, the kind of menu, if you will, of all the critical situational awareness, applications. Another kind of critical piece of functionality here that we wanted to highlight is the ability for interagency information sharing. So we can see in this kind of row of cards, it's a set of data that are coming from an ArcGIS Online group that may contain both public and secure information. So it's really important that we can provide secure access across multiple different organizations for stakeholders and partners to be able to share and access information that they need in a secure way to carry out their mission needs. So this concludes the quick tour of the information sharing capabilities for emergency management operations.
ArcGIS solutions are of immense value during the recovery phase of disaster management. Its field applications prove particularly useful in assessing damage, enabling prioritization of recovery efforts, and efficient resource allocation. Additionally, ArcGIS communicates essential recovery information to the public through maps and applications, displaying damage locations, recovery status, and available resources. Beyond recovery, ArcGIS also contributes to disaster resilience by facilitating data-driven decision-making, scenario modeling, and preparedness planning, ensuring communities are better equipped to withstand and recover from future disasters effectively.
Now let's take a look at the damage assessment capabilities for emergency management operations. Here we're looking at the results of the damage assessment process that have been conducted so far for the Austin flooding scenario. Now we can help kind of continue on with this set of operations here by adding in additional elements here using Survey 123. In this case, these are the standard FEMA forms for individual assistance and public assistance that have been included as a part of the solution template. So now with just a couple of clicks, we can fill out the information that's required, including the incident name. So here from a map perspective, if we zoom into the area where we're starting to and looking to do our assessments, with just a couple of clicks here, I can fill out additional information. So notice here that I have reference information here on the map. I have the parcel IDs, I have the building footprints from FEMA, I have the address points from the statewide 911 database. And so as I click on the map here and fill out my location, it's automatically looking up key pieces of information for me in filling this out, such as the parcel ID, the building footprint ID, the current market value based on the tax assessor information. Now I can continue on and fill out the additional required elements here of this form. And it's just looking for me to validate a couple of things from the location perspective. Obviously I'm going to fill in the extent of the type of damage and the like, and then fill out any other information that is needed here as a part of the request. So a key thing to fill out here is the level of damage assessed. This will mark be used for the symbology for the map as this is filled out, and I'll continue on in the process and fill out any of the additional kind of required fields. Now note here it's automatically kind of calculating the damage estimate here based on major damage based on the current market value. And then finally I can associate photos here right here with a record. Maybe I want to get pictures from a couple different sides of the house and the like. And so now that I've completed my assessment, I'll go ahead and submit that. Now note here that this particular application here that either runs on your Windows device or iOS, Android, obviously your mobile devices in the field. This works if you're connected to the internet or not, and so this kind of process is extremely valuable for being able to go out in the field and do our assessments and complete that kind of in a timely manner, but being able to do that without having to worry about whether you're connected to the internet or not. So now back on the dashboard, we can see that the information here is updated. This represents the information that I just filled out and submitted as a part of the process, and the additional summary information in terms of impacted units and estimated damage here have all been updated to reflect that part of the process. So that Survey 123 form combined with the dashboard here is a very kind of traditional kind of component that we've seen many users kind of leverage as a part of their process. But what we additionally wanted to highlight is there's a broad range of tools here that are part of the process. So there's other elements that we can leverage that really kind of complement this entire infrastructure and ecosystem here of tools. So for example, there's a hub page here, so we can have external information that's shared with the public, which we'll come back to in a sec, as well as an internal destination for our field assessment teams, including the overall dashboard to show how we're doing both for IA and PA. We can talk about the process and give links to help them get started with the various aspects of the form, including providing QR codes for the specific applications that have been configured for this event. We can convey any internal information and guidance that we want in terms of what the different structure and damage categories look like. And again, more details and links to each part of the process, and any other additional information that we want to communicate to internal staff that are conducting the damage assessment. Now, from a public perspective, we can be very transparent and share information as well. The information on the completed assessments so far. We can actually mobilize the public and have them report in where they've experienced damage. So this is critically important to allow us to be able to collect information from the public that we can then later go out and validate. So this can be configured in any way that is appropriate to you, and these set of questions here are completely kind of configurable. Obviously we can type in our address information, and we can expose or hide as many forms here that are important as a part of the information that we're going to fill out. Some of these can be automated, and we can require some of these to be filled out as a part of the process. So again, here I'm just filling out the key fields, and this can be configured in any way that you see fit, based on the type of information that you want to collect from your constituents, including getting photos for them is a part of the process. So we can have them go ahead and submit photos. Now when this is done, this is just simply done in a state that allows us and kind of requires us to go out and be able to go and collect more information and kind of validate this as a part of the process. So in this case, what we're looking at here now is we're looking at a damage assessment operations viewer that is essentially in this case showing us the results of that element that's been submitted by the public. So in this case, we're filtering the requests by default to show the unassigned tasks. So in this case now, I will go ahead and mark that we need this particular request that's been submitted by a member of the public. We want to go ahead and assign that to one of our damage assessment field team members for them to then be able to go out and validate. So that's an important part of the process, is that we can use these tools to help kind of manage the process. And so now our damage assessment field team members can go back to their application, in this case using the inbox feature, and kind of go forth and continue the process of validating that survey. So we won't go kind of through all the steps here, but in a similar fashion now they can fill out all the additional information that was been collected and use this as a mechanism to kind of validate those results. So this this suite of tools here through this damage assessments operations viewer is critically important to kind of walk us through different aspects of the process. We can monitor both the individual assistance and public assistance and see elements kind of come in that are all kind of a part of the process. Additionally, we wanted to note that there is a quick capture form. So in a similar vein to the public reporting in, we can configure a tool that makes it very quick for field teams, especially early on during a disaster, to go out and kind of do a windshield survey and just simply click on the map, and it'll log their location based on their GPS to mark if it's where they are when they hit the big fat button for either individual assistance or public assistance. In a similar manner, we can go forth and validate that later on as a part of the process. So another critical tool that kind of complements a suite of existing tools here to help us streamline our damage assessment process. Now, we did want to note that there's a couple of key administrative tools that are included here as a part of the suite from damage assessment operations perspective. So for example, we can generate a report of this information and being able to communicate that quickly in a traditional tabular format, if that is the way that people are looking for this information. So in the interest of time, we can just simply pull up here a report that was previously generated and open that up and see, kind of the street sheet style of report that was generated. Now, this can be configured with any additional, data elements that are important to you. The reporting elements of Survey 123 are quite powerful and have a lot of capabilities to allow you to configure this type of report to convey any information that you see fit as a part of the process. And then finally, the last element from an administrative perspective that we want to highlight is the kind of the vision of these set of tools, and kind of the last step is to be able to share this in a collaboration group and add in other members that allow access to this information. If from a local perspective, this could be your state partners that can help you validate this information. From a state perspective, this could be your FEMA region and having them gain access to the information to really help expedite this process and really streamline it, and with the important part of getting that recovery funding much faster. So with that concludes our quick tour of the damage assessment capabilities for emergency management operations. Now let's take a look at the damage assessment.
Now we will discuss some of the features and workflows associated with 3 of the flagship field applications in the ArcGIS ecosystem: Survey 1-3, Quick Capture, and Field Maps. Survey 1-3 is a versatile solution for creating, collecting, and analyzing survey data with ease. Its form-centric interface offers various question types, ensuring comprehensive data collection. The application is flexible and usable on smartphone, tablets, and computers. It provides charts, tables, and maps for in-depth survey data analysis. Sharing data is effortless through email, web, or ArcGIS Online. The software's flexibility empowers users to design surveys easily, incorporating logic and calculations. Survey 1-3 proves invaluable to disaster and emergency management, supporting informed decision-making. Survey 1-3 provides 2 distinct tools for survey creation: the Web Designer and Survey 1-3 Connect application. The Web Designer offers a user-friendly drag-and-drop interface ideal for generating straightforward surveys used in the web app. It provides helpful guidance for commonly used question types and behavior, making it suitable for users seeking quick and easy survey design. On the other hand, the Survey 1-3 Connect desktop application offers a powerful solution using XLS Form, a spreadsheet-based markup language. This desktop application allows users to customize surveys to meet their unique needs and preferences. With complete control over survey designs, users can modify and reuse them as they see fit, making it ideal for those requiring more advanced survey customization. Users choose the Web Designer when they seek simplicity and efficiency in creating basic web app surveys without the need for extensive customization. In contrast, Survey 1-3 Connect is favored by users who require more flexibility and advanced features, enabling them to tailor surveys precisely to their requirements. The workflow for creating and using Survey 1-3 surveys offline involves several steps. First, the user will design and configure the map in ArcGIS Online or ArcGIS Enterprise, including the necessary layers and features for data collection. Next, the user will create an offline map package in ArcGIS Pro, customizing it to include all the required geospatial data. Then, the user will publish the Survey 1-3 form, referencing the offline map package to link with the survey in the offline map. Before heading field, Your field data collection team will be required to install the offline map area on the Survey 123 field app. This step downloads the map data to the device for offline use during data collection. In the field, users can collect data without an internet connection, including capturing location and media. Once back online, the user can sync the collected data, integrating it into the main map for further analysis and collaboration. ArcGIS Field Maps is a mobile application that is useful for accessing, collecting, and sharing data on the go. It can be utilized for a variety of tasks, including data collection, inspections, work orders, asset management, and collaboration with other team members. With ArcGIS Field Maps, you can collect survey responses, track asset locations, conduct compliance or safety inspections, create and manage work orders, inspect assets for damage, and share maps and data with others in the field. With ArcGIS Field Maps, you can work offline and collect data without an internet connection. You can also collaborate with others in the field by sharing maps and data, as well as tracking and communicating with them. The benefits of using ArcGIS Field Maps include increased productivity, easier data collection, better collaboration, improved decision-making through access to the latest data and insights, and reduced cost due to the elimination of manual data collection and printing of maps. The workflow for using offline maps in ArcGIS Field Maps consists of several key steps. First, create and configure the map in ArcGIS Online or Enterprise, ensuring that it includes all necessary layers and features for field data collection. Next, package the map as an offline map in ArcGIS Pro, customizing the extent and the level of detail to meet fieldwork requirements. Publish the offline map package to ArcGIS Online or Enterprise, making it available for download by field workers. On the mobile devices of your field workers, ensure that the ArcGIS Field Maps app is installed and updated with the appropriate permissions for downloading and accessing field maps. Using the Field Maps app, field workers can browse available offline maps and download the specific map areas they require for their fieldwork. With the offline map downloaded, field workers can conduct data collection without an internet connection. Once fieldwork is complete and an internet connection is available, field workers can synchronize the collected data back to the online map, ensuring data integrity and enabling seamless collaboration with the main GIS system. ArcGIS Quick Capture is a powerful application designed for rapid field data collection, featuring a unique big button approach for swift and efficient data capture. Ideal for GIS professionals and non-technical users alike, this user-friendly app simplifies inspections, surveys, and work order management, ensuring real-time data collection with ease. With quick capture templates and customizable forms, setting up data collection projects is quick and easy, saving valuable time and effort. Moreover, the app's offline capabilities empowers data collection in remote or disconnected environments, eliminating internet dependency and enabling data capture at any time or location. The seamless sharing of data among team members fosters collaboration and enhances decision making. Its intuitive big button interface ensures rapid proficiency with minimal training, making it an indispensable tool for diverse field data collection needs. To make the most of ArcGIS Quick Capture when operating in offline or disconnected environment, a well-structured workflow is essential. Firstly, create your ArcGIS Quick Capture project online using the web application. The user-friendly interface facilitates designing data capture templates and customizing forms tailored to your specific data collection needs. This step allows you to plan the project efficiently before heading to the field. Prepare your data for offline use by ensuring that all the necessary data layers and templates are included in the project. Define the extent and level of detail required for offline data capture, ensuring that all relevant information is available during fieldwork. Download your project to your mobile device through the ArcGIS Quick Capture mobile app. This crucial step enables you to access the project and its data even when you're offline, ensuring a seamless and uninterrupted data collection experience in the field. Activate the offline mode in the Quick Capture application before heading into the field. By enabling this setting, you can confidently capture data without an internet connection. All the data collected is securely stored on your device until you have the opportunity to sync it with your main GIS system. With your project now available offline, you can collect data in the field using ArcGIS Quick Capture. The app's pre-configured templates streamline your data collection process, making it efficient and straightforward. In 2019, the Office of Disaster Preparedness and Management identified a delay in the collection and delivery of data from the field to the ODPM and the Ministry of Rural Development. However, a swift and efficient solution was needed to address this issue. To create a comprehensive national disaster assessment form for Trinidad and Tobago, the ODPM utilized several essential tools, including Survey 123, Quick Capture, and Field Maps. The Ministries of Rural Development and the Social Development were consulted to ensure a comprehensive survey form was created. Survey 123 was used to collect data, while Quick Capture was employed to gather real-time incident data, swiftly. Field Maps was also utilized to enhance the accuracy and completeness of the data collected. All the valuable information collected was consolidated and presented through multiple displays using ArcGIS dashboard. We at Spatial Innovation and Esri are confident in our ability to collaborate with you and optimize your disaster and emergency management procedures through the use of ArcGIS. We appreciate your attention and time and are prepared to answer any questions you may have.
Thank you, Kevin. So now we accept questions. You can utilize that question option or the question and answer